Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 8 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually the sponsor of this series of video lessons. And in these lessons, we are using the most excellent Sunfounder Ultimate Raspberry Pi Starter Kit. And guys, seriously, your life and my life are going to be a whole lot easier if we are working on identical hardware. Great kit. I'm having a lot of fun with it. You guys that already have it, hopefully you're having fun with it. If you don't have your gear yet, look down in the description. There is a link over to Amazon where you can pick one of these up. But enough of this shameless advertising. Let's talk about what I am going to teach you today. And what I'm going to teach you is I'm going to show you my solution to the homework assignment, which I gave you in lesson number 7. And what that homework assignment was to create a toggle switch based on a button where you could toggle an LED on or off. And I think I can come over here and show you what the assignment was. I have mine already working, and then shortly I will show you how I actually did it. But you can see I have the switch. If I have the button, if I press the button, the LED comes on. And if I press the button again, the LED goes off. Now, this is not, the button itself is just an on-off button. You're taking that on-off button and you're turning it into a toggle switch. So how many of you guys were successful? If you were successful, leave a comment down below. I am Uber legend. And if you were not successful, leave a comment. I folded up like a cheap Walmart lawn chair. Now, like I told you in the homework assignment, this is really very straightforward, but it's something that until you get your mind around it, it is just seems like it is impossible. It is just a terribly, terribly hard thing. So like you can either do it the easy way by thinking, or you can do it the impossible way, okay? So as always, what I'm trying to do in this series of lessons is I'm trying to get you to start thinking like an engineer, okay? And how do engineers think? They get it working on paper first. They kind of work it out on paper, and then after working it out on paper, then the coding is really easy. But the mistake people make is they just jump in and they start coding and trying to make it work in Python before they really have it scoped out, have a strategy scoped out on paper. Does that make sense? Well, I hope some of you guys were able to get this figured out, but I'm going to jump in, and what we're going to do is we're just going to kind of talk through this thing, and we're going to talk through this thing with our sketch pad here. Now, just thinking about it, the first thing is I'm going to think in terms of I have an LED. Okay, I've got an LED like this. And then I have a push button switch over here. And this switch is either not pressed or it is pressed. So the switch is either open or closed. And then the LED is either on or the LED is off. Okay, so the LED is either on or off, and the button is either pushed or it's up. Okay, if it's up, it's in a 1. If it's pushed, it's in a 0, because right, we're using a pull-up resistor. You should understand that now. Okay, sounds like, now, what is it that's going to make the LED switch? Okay, what is going to make the LED switch? And I tried to, in the homework, I tried to kind of emphasize this. Now watch this, okay? If I hold the button down and then I let the button up, it switches. If I hold the button down and I let the button up, it switches. So if the button is down, that's a 0. And if the button is up, it's a 1. So when do I want to switch the LED? When the value on the LED goes from 0, or when the value on the switch, when the value on the button goes from a 0, which is pushed, a 0 which is pushed, to a 1. So when the button goes from a 0 to a 1, I want to flip the LED. Well, if I'm going to flip the LED, I need to keep track of what? I need to keep track of the LED state. Okay, the LED state. The LED state is a variable, and that variable is either going to be a 1 or a 0. Okay, it's a 1 if it's on, and it's a 0 if it's off. Okay, so if I need to know, is the LED on? I just say print LED state. If it's a 1, the LED is on. If it's a 0, the LED is off. And so do you see that that is a pretty simple concept? You got to keep track of, is the LED on or off, and you keep track of that in LED state. Simple enough, right? Now also, you're also going to need what? You are going to need a button state. You're going to need a button state. So this is one variable, which is LED state. Now this is a second variable, button state. Now what is button? Button state is a 0 if it's down, if it's been pushed, and it is a 1 if it is up. Okay. Two variables, LED state, button state. Now, when do I want to switch LED state? When button state goes from 0 to 1. So I need to not only know where button state is right now, I need to know where button state was the last time through the loop. So what I need is I need another variable, which is button state old. Okay, that is the last time through the loop. What was the button state? Well, it could be a 0 or it could be a 1 if it was down or up last time. So when do I want to switch? I want to switch if what? If button state is a what? If button state is a 1, and if button old, okay, no, let's see, if button state is a 1, which means it's up, and if the last time, if button old was a 0. So when do I switch? I switch if button state presently is a 1 and last time button state was a 0. So let's go back and let's look at this. And maybe this is easier to you guys than it is for some people, but I'm just being really deliberate in explaining this. Right now it's up, so button state is 1. I press it down, button state is 0. Nothing happens. Button state is 0. When it comes up now, button state goes from 0 to 1, and you switch the LED. The LED state flips. Okay, so in order to make this thing work, it's really, really, really simple. What do you need? It's really, really, really simple. What do you need? You need an LED state that you keep track of. You need the present button state that you keep track of. And you need the old button state that you keep track of. Simple as that. Okay, let's see if we can code this thing up. So I guess I should jump in and just remind you of what our circuit is. This is the circuit that we are using. We are using the push button switch, and the left leg of the push button switch is hooked to pin 40, which is the lower right GPIO pin, and then the right leg of the button switch is connected to ground, which is pin 39 on the Raspberry Pi. And then the LED, the long leg, we are going to GPIO pin 38. Then we're going to through our 330 ohm resistor, and then ground goes back to pin, let me just look to make sure I don't tell you wrong. That ground, we're using pin 34 there. We're using Raspberry Pi pin 34. Okay, so now let's come over here and let's see if I can give you a code view. That is not very good there. I think this is the one that you want here. And then I'm going to need to take a second here. All right, so that looks good. So we are going to clear this. Start up at the top. All right, so now we are going to start coding. So what I'm going to do is I'm going to create a new program down in my Python directory, and it's going to be called toggle led.py because we're going to toggle that LED on and off. All right, so now let's get busy. We're going to need to have a delay in there. So from time, we are going to import sleep like that. Okay, then we're going to use the GPIO pin, so we're going to import rp_i.gpio, and we're going to import those as GPIO. Now I'm going to need a delay in there, so I'm going to set my delay to, let's say, 0.1. That's usually a pretty good one. We have our in pin, which was the lower right GPIO pin. That's our input pin that we have hooked to the switch. That was pin 40. We have an out pin, which was the one right above it, which was GPIO pin 38. Now we need to do a GPIO.set mode. And what are we going to set? We're going to set it to GPIO.board, saying we're using the physical numbering system on the GPIO pins. Okay, now we got to be a little careful here. We're going to do a GPIO.setup. And what are we going to set up? We are going to set up our out pin, and we're going to set it up as a GPIO.out. That's pretty straightforward. Now this is your money line of code here. This sets up the internal pull-up resistor. So that's going to be on the in pin, and it's going to be a GPIO.in. And now I've got to tell it pull up down. We're going to use the pull up down, okay, and that's going to be equal to GPIO.pull up down PUD. And then what is it going to be? We're going to use a pull up resistor, and that way we can just use the switch, the toggle switch, or the push button switch by itself. We're going to use the push button switch by itself without the external pull up resistor because we're doing it internally this time. Okay, hopefully that all makes sense now. Okay, so that looks good. Now we've got to set up those variables. Remember we said we were going to keep track of the LED state. Well, the LED is going to start, it's going to be off. So we're going to set that to a 0. 0 is going to be off. So the LED state starts out as 0, off. And then the button state, it is up. And in the up position, with a pull-up resistor, that is what? That is a 1 value. And then we also have to give it a button state old. Well, since we haven't done it, since we haven't pressed it when it runs, it's going to start out as a 1, and last time it would have been a 1 as well. So we're just going to start them out both as 1 to initialize those variables. Now we're going to do our try, and that will allow us to exit cleanly. Remember, we're going to do a try and accept. I'm going to spell accept right this time. How do we accept? We accept on keyboard interrupt, if I can spell, and that colon does not go there. Okay, it'll be like that. And then what do I put here? What do I put here? I'm going to put GPIO dot clean up like that, and then I'm going to say GPIO, I'm going to say print GPIO good to go. And that just tells me that they were in fact cleaned up, because sometimes if your program crashes, you haven't actually cleaned them up. Okay, so if you hit the Control C, it's going to jump down here to the accept. But if you haven't, you're going to be here and you're going to have a while loop. So I'm going to say while true, when is true, true, true is always true. So this is going to be an infinite loop. What do I need to do? I need to read the what? Button state. I need to say, where is the button? So the button state is going to be a very simple GPIO dot input, and I'm going to read from the in pin. So now I will know, has the button been pressed or has the button not been pressed? And so as I'm just sitting here, it's going to be reading a 1, 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 because I haven't pressed it, okay? And then we can even, just for fun, we can say print button state, just so we can see what it is. Print, spelling is very important in Python. Like that. Okay, so I'm going to print it out. Now, when would we want to switch? We would want to switch if button state equal 1, which means it's presently up, and button state old equal what? 0. So I'm saying if it's presently up and last time through it was down, if it's presently up and last time through it was down, then what do I want to do? I want to I want to switch the LED. So how would I do that? Well, I would say my LED state, lowercase s, LED state, it started out as a 1. It started out as a 0. The LED is off. Now I want the LED to be on, so I want to switch it. So LED state is equal to not LED state. Okay. LED state is now not LED state, which means if it was a 1, it's going to become a 0. If it was a 0, it's going to become a 1. Now, you might cry foul and say, well, you haven't taught us not yet. Yeah, I haven't, but what you could do here is you could put an if statement. Inside of the if button state, you could now put an if statement. If LED state is equal to 1, then LED state equals 0, or if LED state equals 0, then LED state equal 1. So you could put 2 if statements and you could do the same thing. So you had the resources to make this work with what I've taught you so far. Okay, you have the resources to make this work based on what I've taught you so far. Let's make sure you can see what I'm doing here. Okay. Yeah, now you can see it. So LED state is equal to not LED state, or you could put the 2 if statements in there. All right. Then what do you need to be sure and do? Now that I have the LED state, I need to GPIO dot output. And where do I output it? I'd output it to the out pin. And then what do I output to the out pin? LED state. It'll output a 0 or a 1, turn it on or off. Does that make sense? Now this is your money line of code here. What do you have to do? You have to pass forward what your present button state is. So I've got to set it up for the next time through. The button old value, button old state is equal to what? Button state. Do you see what this is? This is like dropping a breadcrumb, because when I get to the top of the loop, I'm going to need to know what button state was last time. Well, what was button state last time? It was button state old, and so I've got to set button state old to button state as I'm getting ready to go through again. If that doesn't make sense, pause the video and think about it, because that's kind of a key concept to make this whole thing work. Button, I think I did that wrong. Button state old. I did it wrong, sorry. Doesn't count as a mistake if you catch it before you run it. Button state old. Like that. Button state old is equal to button state. Could it really be that easy? How many mistakes are you guys yelling at me about here? How many mistakes have you already caught me making? And how many mistakes are you yelling at me about? All right, let's do a control X. Let's do a Y and then a enter. Okay, and now we're going to come up, and instead of nano, we are going to Python 3 it. I need everyone to hold their breath. Oh, denied. Line 2. How could I make a mistake in line 2? Let's look at that. Import PR. That's my old dyslexia keep kicking in. Were you guys yelling at me about that? Control X, Y, enter. Okay, hold your breath. The reason it didn't work is one of you guys out there, and I think you know who you are, did not hold your breath, and that made my code mess up. I need everyone to hold their breath. Oh, line 8. Okay, what is that? Pull up, down, GPIO. Pull up, down, up. GPIO.in. That looks good. Input. Oh, wet up. Oops, that's a bad one. Nano. Okay. What was that? Where on earth was that? That setup. You guys were probably yelling at me over that one. Control X, yes, enter. Really, everyone hold your breath. Okay, what did I forget right off the bat? I see I forgot my delay, so I'm going to go back and I'm going to go in and I'm going to nano it, and hopefully you guys saw. So where would be a good time to do the delay? Down at the bottom of the loop, I think. Down at the bottom of the loop. After I've done this, I can just say, I can do a sleep, and I want to sleep by delay, and I want to sleep by delay. Why? Because that was what I set up at the top. Control X, Y, enter, and now we're going to Python 3 it. Hold your breath. Okay, now is that what we expect? Well, the button is not pressed. The button is not pressed. The LED is off, and it's reading a 1. That looks good. Okay, all eyes on the LED. I press the button, I hold it. It's reading a what? A 0. Moment of truth. Shazam! Who's your magic man? Me. Look at that. Toggle on. Let's see if we can toggle on. We'll hold it down and let it up. Toggle off. Look at that. Works pretty good. So we turn our light on. We go about our business. We are ready to leave. We come in and we toggle it off. That is pretty darn good. Okay. Now, I want you to think about, you could have done this a different way. I switched on where? Like if I hold the button down, it doesn't come on until I what? Until the button up. You could also do this switch on what? Switch on button down. You could also do it that way. So let's see if we could do that. So how would we do that? How would we do on the switcheroo on the button down instead of the button up? Well, you would do that. It all comes down to this. That would mean if I am presently down, which is a 0, if I am presently down, which is a 0, and I was formerly up, which was a 1. So if I go from a 1 to a 0, I want to switch in that condition. So I'm going to control X to save, Y, and then enter, and then let's up to Python 3 it, and then we're going to hit an enter. Okay, it is off. Now watch this. I come in, I press down, and it goes on. Okay, now watch this. I press down, and it goes off, and then I let up. Okay, so you see you can do it on whichever transition you want. Who is the master of the toggle switch? You are. You know how to do that now. And guys, this is really important because lots of things, like imagine you wanted to turn a motor on with the toggle switch. You would want to come in, press the switch, have the motor come on. You would want to come in later and press the switch and have the motor go off. And so turning things on and off with these very simple switches, you've got to understand this toggle concept. And so hopefully that makes sense for you guys. Let's see, I think I need to switch back over here. Let's see if I can get get it. All right, so we'll switch back over here to the river view. If you look above my head, I know you guys like to see the fishermen. There's one right over there. You can see we have a guy working on bananas. We have a guy working on bananas right there. It looks like there he is. And so I know you guys like to look for your fisherman friend in the background as we're doing these lessons. But man, I hope you guys are having as much fun taking these lessons as I am making the lessons. Now, what your homework assignment is for this lesson is, if you are not able to do this on your own, at least go back and do it now without watching me go back and code the whole program up without looking at what I did, so that you can say, okay, it's in your head, you understand how to do it, and at least now you can do it. At least now you can do it by yourself. You guys, as always, I want to give a shout out to all of you who are helping me out over at Patreon. It is your support and your encouragement that keeps this great content coming. If you're not helping out yet, look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. Also, as always, if you like this video, be sure to give us a thumbs up, leave a comment down below. Both of those things help us with the old YouTube juice, which allows YouTube to show this video to more people. Also needs you to share this with your friends, because the world needs more people doing engineering and coding, and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.